Hey kiddos, in this lesson we're going to go through lesson 5.5, which is all about factoring expressions. Now for factoring expressions, it's when we are doing sort of the opposite of distributing property, which is when we multiply to whatever's in the parentheses. Factoring is finding, hey, what number or what factor is in common with whatever's in parentheses that we can sort of pull out. And so for this, for the criteria for success, we're going to need to understand the distributive property, and we're going to need to be able to identify the greatest common factor in terms for the terms that are being expressed in the expression. So, as a reminder, when we're talking about factoring, writing a numerical expression or algebraic expression as a product of factors is called factoring the expression. And we can use the distributive property to factor expressions. So factoring numerical expressions, if we're looking at the following expression of 18 plus 30, the first thing that we're going to need to do is determine what is the greatest common factor. What factor do these have in common so that we can then factor that value out? So when we're looking at the factors of 18, what are all the numbers that we would need to multiply in order to get 18? What would they be? They'd be 1, 2, 3, 6, 9, and 18. And what are all the factors for 30? Factors for 30 would be 1, 2, 3, 5, 6, 10, 15, and 30. And when we look at those two lists of factors, what do they have in common? Well, they have 1, 2, 3, and 6. But 6 is the greatest common factor. So that's going to be the factor that we pull out. So when we look at 18, 18 divided by 6 is equal to 3. So 3 times 6 is equal to 18. And what about 30? Well, 6 times 5 equals 30. So that's 6. Again, is the greatest common factor. That's what we're factoring out so that we can rewrite our expression. And now we use the distributive property to rewrite the whole entire expression of just 6 times the quantity of 3 plus 5, because 6 times 3 would be 18, and 6 times 5 would be 30. Let's take a look at another example. 20 minus 2. Want to find what is the greatest common factor, and then we want to distribute or pull out that factor so that it can be distributed to the other two factors within the parentheses. So we first are going to list what are all the factors for 20. They're 1, 2, 4, 5, 10, and 20. What are all the factors for 12? They are 1, 2, 3, 4, 6, and 12. Once again, we look at what are all the factors that they have in common. They're 1, 2, 4. And now we are going to choose the greatest common factor, which happens to be 4. And that's what we're going to pull out to rewrite our expression. So when we rewrite this expression, it's going to be 4 times 5 and 4 times 3. And we want to pay attention, kiddos, to that operation. The operation in this case is subtraction, so that's not going to change. That still is going to remain the same. So we are going to have 4, let's go back, 4 parentheses, 5 minus 3, because 4 is being factored for both 4 times 5, which gives us 20, and 4 times 3, which gives us 3. Let's actually try this. When we're looking at the following, and we see 9 and 15, what's the greatest common factor for 9 and 15? Looking at this and we see all of the factors for both 9 and 15. The ones they have in common are 1 and 3, but 3 is the greatest common factor. So what does that mean? That means, let's erase this. With 3 being the greatest common factor between these two, we're going to factor out the number 3. And 3 times 3 would give us 9, so we're going to write 3. And 3 times 5 would give us 15, so we're going to write 5. And then the operation, because it's the addition, we're going to put the operation of addition in between. Let's go ahead and erase this. I don't know why that's still there, but we'll let it be. All right, taking a look at 60 and 45. What's the greatest common factor for 60 and 45? Well, there's 1 times 60, 2 times 30, 3 times 15, 3 times 20, 4 times 15, and then it's just in reverse. It'd be 5 times 12, and then 20 times 3, 15 times 4, and 60 times 1. For 45, the greatest common, or the factors for 45, 1 and 45, 3 and 15, 9 and 5. So what they have in common, or the greatest common factor for those two, would be 15. 15 times 4 is 60, and then 15 times 3 is 45. So with that in mind, going through those two examples, that is how we are going to factor expressions. Using the distributive property of 1, find the greatest common factor for whatever the expressions are, factor that number out, listing whatever the factors are so you can see what the greatest common factor is, pull that factor out, and then within the parentheses, what are you going to multiply that factor by in order to get the original, original expression. All right. So let's go ahead and erase this. Let's take a look at our next slide. Now, what do we do when there is an algebraic expression that we need to factor, meaning that there are some variables and maybe there's a coefficient along with a constant? Well, we're going to use the same exact steps that we've been using before, where we're going to find what is the greatest common factor, use that greatest common factor for the two terms, and then factor that out. So when we look at 3x and 42, we have to ask ourselves, what is the greatest common factor for them? Well, for 3x, it's just 3 times x. That's how you get 3x. And what about 42? Well, 42 is 2 times 3 times 7 using prime factorization. What do they have in common? Circle the common prime factors, which in this case is 3. And so we're going to factor out the number 3, and that's going to be outside of the parentheses. And so when we rewrite this expression using prime factorization, we're going to have 3 parentheses x plus 14, because 3 times x gives us 3x, 3 times 14 gives us 42. Let's take a look at letter B. Actually, let me pause, give you kiddos who are watching a moment to synthesize what we just talked about. Now let's take a look at letter B. If you at any point need to pause, if you need to go over this again, go ahead, rewind the video and listen to it one more time. Letter B, we want to factor out 63z as well as 27 using prime factorization. When we're looking at 63, it's just 63 times z, which is 3 times 3 times 7 times z. And what about 27? 27y, excuse me. When it comes to 27y, what's the prime factorization there? It's 3 times 3 times 3 times y. Now, what do they have in common? They have the two sets of 3s, or 3 times 3. When we multiply 3 times 3, hopefully we recognize that's 9. 3 squared is equal to 9. So we're going to be factoring out 9. 9 is the greatest common factor for these two terms. When we do so, we have 9 times 7z, and then 9 times 3y. And when we rewrite our expression, once again, we're paying close attention to that operation, which is the subtraction sign, so that it's 9 parentheses 7z minus 3y. We're going to try one example together, and that'll be it for today. So when we're looking at this expression here of 7x plus 49, what's the greatest common factor? Well, using prime factorization, we know that it's just going to be 7 times x gives us 7x. And then for 49, it's 7 times 7. What do they have in common? They have 7 in common. And then what are we left with? X plus 7. So when we factor out this expression, we have 7 parentheses, x plus 7 as our new expression. What about number 2? This is 8. And if we're using prime factorization for this, this would be, let's erase this, it would be 2 times 2 times 2 times y. And what about 44? 44 would be 2 times 2 times 11 And what do these two have in common? 2 sets of 2, which means that the greatest common factor, 2 times 2, is going to be 4. And what are we left with? We're left with 2y and 11. And the operation is subtraction, so we're going to write minus 11. Kiddos, at this point, once again, I want you to make sure that if there is anything that you are not understanding, if there's anything that you feel unsure about, please, please, please say something to myself, check in with me during office hours, or send me an email.